Okay, so when we left off in the last video, you were trying to place these numbers where they belong on a number line. This is something that you may want to be able to refer back to. Definitely going to be useful as we start talking a little bit more about irrational numbers and square roots of numbers that are not perfect squares. So I would take a moment to pause and work on putting these where they belong on a number line. It may be helpful to not only list them as the square root of 1, the square root of 4, the square root of 9, etc., to actually calculate what that square root is to help you figure out where they belong. So again, you can pause and work on putting these on the number line in the appropriate location. Okay, so now we're going to really get into some more detail about irrational numbers. Like we had in our definitions, this is a number that cannot be written as a fraction or a repeating or terminating decimal. The very most famous irrational number, we just celebrated this day last week, is pi. Pi is well known for never terminating and never repeating. I know in class we talked about how it's impossible to list all of the digits of pi because it never ends and there's no pattern. There are lots of other irrational numbers. Pi just happens to be the one that we are most familiar with. Another good example would be non-perfect squares. So far, we've mostly been talking about the square roots of perfect squares. So now we're going to start looking at the square roots of non-perfect squares. It says at the bottom, what would an example of a non-perfect square be? This is basically any number that is not produced by multiplying a number by itself. Okay, so we know 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. But 5, 6, 7, 8, all of those would not be perfect squares. And when we try to take their square roots, we're going to get a number that's really ugly. So that's kind of what we are getting into here. Okay, so next I want you to take a look at this list, each of these square roots, okay? Some of them, for example, I can show you one. Some of them we know the square root of. For example, square root of 121. 121 is on our perfect squares list. So when we take the square root of that, we get 11. Because of that, that makes this number rational. Okay, other numbers like the square root of 5, 5 is not a perfect square. So we are not going to be able to get a nice pretty number like 11. That makes the square root of 5 irrational. So what I want you to do is copy the rest of these examples into your notebook and then determine whether they are rational or irrational. So you can pause the video and do that now. All right, so if you want to check your answers, square root of 23, that is going to be irrational. The square root of 169, that's going to be rational, that's 13. The square root of 54 is irrational, that is a non-perfect square. Square root of 90, also irrational. Square root of 44 is irrational. The square root of 100, which is 10, is actually going to be a rational number. Okay, so the next thing that we are going to work on is we're actually going to be completing this table. So pause your video. You are going to copy the table. I know it's hard to see that bottom number. That is a 0. So copy the table into your notes, and you are going to check off all of the different categories that each of these numbers would fit into. So pause the video and you try that for yourself. Okay, so I've filled in the chart so that you can check your answers. So please do that. I would make any corrections as needed. Note anything that you have some questions about. Okay, so the last thing that we're going to do in class today is you're going to work on IXL 8th grade I.2. You are trying to get to a SMART score of 70 on that. It's just identifying rational and irrational numbers. We're going to skip this exit ticket, but when you're done, this is going to be your homework. So please be sure that you get that done.